Good afternoon, Professor Emami, and welcome to this interview for BioTrib. You're one of the kind of co-investigators on this particular grant. You work at the Luleå Technical University in the north of Sweden. And for the kind of participants and for the wider community, could you just briefly outline your career and to date, what have been your interests and how those interests have changed over the years as you've developed as a researcher?
Thank you for having me, Richard. So it's wonderful to be here today and talk about biotribes and also a little bit on the side spore of it. Well, career background that I can say for me has been really, I started different path and I'm in a place that I would never thought I would be at where I am. So I started my dental education, which I finished in 1994, and 1995 I moved to Sweden. Practiced for a few years and I realized that's not really what I wanted to do. So I looked around a little bit, did a couple of courses on polymer science, which I was quite interested in because as a dentist, I worked with light cure dental composites, which I had quite fascination about it. And that is actually where I started my research career, doing a first few courses, as I said, then a PhD on dental biomaterial, which I concluded and finished in 2004. Then I did a postdoc on interfaces in Australia at Work Research Institute with the Swedish Research Council grant with actually the highest grade, which is not easy to get. I was very lucky and happy to have one of those grants, and back to Sweden 2008, end of 2008, and since 2009 have been here at the Division of Machine Elements working on polymer tribology. And having said that, that covers quite a umbrella of applications, but one of them which I should say, and I would say bravely, it's closest to my heart is actually biomaterial, because that's where I started my career. And that's where I actually know the terminology best and sort of feel very much comfortable. So doing polymer tribology research over the last 10, 11 years has been the center of my research.
Okay, when you first set out on your dental career, when you first became a kind of a dental a dentist. Were you a dentist? Was that right?
Yeah, it was general. Yes, I was a DDS because I did even extra courses to do small surgeries, but nothing for me. No.
So when you moved into a material science area, I presume doing that you brought a fresh perspective, a new perspective into that particular domain. What did you find challenging about moving to a material science domain?
The challenging part, of course, not knowing maybe what the students learn in undergraduate. So I had to jump in at higher level of the master level to grasp what they had learned in undergraduate. What I had as the advantage for me, a knowledge and understanding of biomedical application and medicine, which was needed for what I was doing. So in that aspect, I was ahead of other students, understanding dental biomaterial as a practitioner. So I was working with them. I knew the patient problems. I knew how dentists works. I knew the company was selling them, the weaknesses, the advance. So that gave me advantage, being the multidisciplinary part. But being a multidisciplinary also has a disadvantage, is that you could lose the depth. So one has to be very careful to gain also the fundamental in that.
Okay, thank you. So this is 2021. You're involved in a number of European projects. You're involved in Green Tribos, which is a European joint doctorate with 3 universities around Europe, of which Leeds is one. But I suppose the focus of this one is you're also involved in BioTrib, which looks at biotribology. And it's largely focused not just on what we would call traditional joint tribology, but there's things about 3D printing of materials, there's about self-lubricating surfaces. And so could you just briefly outline the 2 projects that you're involved with in BioTrib?
Exactly as you mentioned. So my interest also is in both manufacturing the polymer, because that's where I have my interest. to making these composites, and then further characterization, mechanical, surface, interface, tribology, biotribology, medical, biocompatibility. All these things are like a bonus coming after that. So the most exciting part for me is always to make new material and then bench it against commercial material and hopefully to see, okay, we are this many percent better in different sort of property, performance, life expectancy, and how we can even take it further. Because I think considering today's society, not only in Europe, even world, it's not enough anymore to make incremental improvement in small focus areas or subjects. We need to think holistically. We need to think the whole picture. We need to make material which is recyclable, which we can reuse again, which have no, or at least as little as possible, impact on the environment, even if it's in medical aspect or engineering aspect or any sector we are working with. So I actually, when you mention green tribos, I see quite a lot of interfaces which are common in my both project. I have other applications for polymer, but bringing biotribology or bio applications closer to more fundamental topics, I think it's interesting and it's important. It gives us a better understanding of the material behavior and manufacturing of them.
Mm-hmm. Certainly, when I look at my colleagues in the Institute of Functional Surfaces who do a lot of work around corrosion and material kind of properties and kind of more traditional tribology in the oil sector, or where they link tribology with corrosion, and there seems to be a lot of advancement in the fundamental work there, both in terms of the technologies to sense the environment, I suppose, and sense the wear, particularly in situ. How do you think those technologies can be applied to biotribology, which, medical engineering always seems to be one of the last areas which kind of takes up new technology somehow?
Well, I think for good reason, that medical technology a bit late, and that's the sensitivity of the subject. It's make it more complicated. I mean, when I see my colleagues or my other projects, which is with Vattenfall or SKF or Volvo or any other big companies, that's a different specimen than coming and putting the implant into the patient's sort of body and see what comes out of that. So because of the sort of our sensitivity of the applications and the ethical approach of it, so it's become more time consuming. I mean, the nanocomposites, which I'm working with over the last 12 years, I have applied it in many engineering application. Even we have good results, we haven't been able to come even close for biomedical application. And that's because once you bring the word nano into the whole pictures, and then I'm in a very, very long sort of group, in the group which has the most complicated evaluation for being able to get the certificate, FDA certificate, to be available on the market. So maybe it's for a good reason that it takes more time for biomedical to. On the other hand, biomedical is more also, if I compare it with mechanical engineering as a traditional engineering, especially machine component, it's much more also advanced in being modern. Because the traditional combustion engine, has been around for how many years now? And now it eventually is changing. So I think still renewable is admirable in biomedical application, even if it's time consuming to get to the market.
Okay, thank you. And as part of these projects, you have links with both China and with Joanne Tipper in Australia. Could you just give me a brief background of how you developed those links and why they're important to the project?
Absolutely. I mean, Joanne and Leeds University, we have our research group here in Luleå, and Leeds has a very long tradition of knowing each other and friendship and collaborating. Our head of the group, Roland Larsson, was there when he was a PhD student. So this is early 90s. And Duncan Dawson, he was a very good friend of us, which actually he was a key person for me to getting into the biotribology. The first tribology conference I ever attended as a just observer was Leeds Leon in Leeds, and I had the opportunity to sit and talk with Dawson for hours. So having him as a mentor, starting my biotribology sort of path, this is 2006, before I went to Australia. So it was very important for me. And friendly people, lovely scientists, both Joanne and Anne I got to know through Duncan, and I have worked with both of them for many, many years. So I'm happy to continue my collaboration with Leeds University. And now Joanne, when she moved to Sydney, so it will be Australia for me because she's there.
And what about China? You got
China is actually kind of pure by chance, because we were invited to participate at Lanzhou's international conference. They actually had for many years with Southampton University. And we got invited to participate 2018 at one of those international symposium in Lanzhou. So over there, when we met fantastic scientists, sort of beautiful research, they are very fundamental research they are doing on solid lubricants and polymer science. Those of us had common interest, got the interface and possibility to talk and exchange ideas. And Professor Wang was doing lots of 3D printing, nothing in the application I'm interested in actually. He's more in bio-inspired material, but still we had a common interest. And since 2 years ago, we are working together.
Okay. And you also, as we mentioned previously, and also you've highlighted, the common kind of interfaces between green tribos and kind of BioTrib. The green tribos initial training network is quite unique, though, isn't it? It's one of these European joint doctorates.
Mm-hmm.
Could you just explain what a European joint doctorate is, and how that's kind of, and the importance of such networks in kind of the European domain, as it were, the European research area?
Well, the reason we were brave enough to take such a challenge, such a European joint doctoral degree, was because we had already a master together within the consortium. And that is actually, I think, the only tribology master program in Europe, which is Erasmus Plus program. And also it's a true joint degree. So which behind that signature for sort of vice chancellor signature on the same diploma, it's a 4 years, 3 years of administrative work and the legal process. So very challenging and very rewarding. I have learned so much about all those three universities, sort of administrative, and actually how we build our education, because that's what we had to evaluate against each other. How do you build your master program where we have compatibility, where we don't have? So having the tribos since 2013 was this core central stone for us to build the same program on top of that in the PhD program. And again, a year and a half of legal procedure to get the agreement between universities for the double degrees, because that's what is the center of the European Joint Doctoral Program. But we were lucky, we did it, we finished it, and happy now to work within the consortium, actually.
So how did you reconcile the different kind of requirements of the degrees? I presume, particularly a UK degree where there's no kind of formal education part of it. It's just basically a straight research program for 3 to 4 years. I suppose in essence, you know, that all the universities do the same amount of research, but these kind of these course differences are kind of substantial. But also there's, you know, on the continent you tend not to have a transfer, but a later assessment.
Yeah.
And
I think what I have learned to be humble, and it's in our way is not always the best way. So that's one has to be very open-minded to listen, take in, reflect, and see maybe in this Leeds do better than us, how we can adapt ourselves to the way Leeds do. Or sometimes there is Coimbra University, maybe do something more wise and they have more experience. So that's actually what we have done. We have listened, reflected. And as a researcher, it's easy for us, but to make that a legal document, there are obstacles, there are regulations, there are rules and laws that it's the most important to keep it in the framework of the legal, but then it has to be explained and also adapted so we can I think what we have done is to learn the best of each other and try to adapt. Since I know, for example, transfer report is actually very important for Leeds. So that means that we introduce that within our program as well, that all of my common students with Leeds will do a transfer report according to Leeds regulation and know. So it's maybe a little bit more work for students, but if I compare our green tribals students with our regular PhD, they are served so much more. They have so many courses, they have so many opportunity, all these training events we have had. We have so far 2 of them, fantastic presenter, fantastic workshops, seminars, the lecturer. I mean, this is a gold opportunity for any early career student to start a fantastic sort of education. This is not happening in our regular, because here we have the facility for it. We have got fund and we have the possibility to offer them that extra, which is good to see they are also taking on.
Yeah, absolutely. I couldn't agree more with you on that point. The opportunity for networking and the opportunity for these high-end courses, I think, is excellent. And finally, how would you like to see kind of this sort of research, this early stage career training developed within a European context, or a Swedish context for that matter?
Well, actually, it's more European and even global context for me than Swedish context. I mean, what probably the COVID pandemic gave us a good lesson that it's not about Sweden anymore. It's not even about Europe. So we are all, once we are in trouble, all of us need that vaccine, whoever is producing it. Is it China, is it India, or is it United States? So I think what I would like to see, that more coherent collaboration in Europe gives us more strength and for the future. And also, as you are trying such a good job to combine our ESRs within green tribals with BioTrib ESRs when they come here. And I think that's we should definitely do. So there are lots of experience, knowledge among these ESRs, and God knows where they will end. They will be very close collaborator and maybe researcher working in the same institute not many years from now. And I think I would like to see Europe working more together, closer in all the aspects, and we should solve our problems more closely together. So I think we need each other. So that's it has been proven for all of us. And even if UK is not anymore in Europe, I never see them outside Europe. For me, UK is always in Europe because nothing has changed in our collaboration.
Well, we're still part of Europe. We're still
exactly.
that island,
yes.
or that set of islands off the
exactly.
northwest of France and Belgium. So
yeah.
hopefully,
so I'm happy. Yeah, and I'm happy to. Nothing in our research has changed, and we look forward to continue our collaborations as well.
Okay, thank you very much. That's been excellent and most informative, Professor Emami, and I'd like to thank you for your time and your contribution. Thank you.
Thank you, Richard. Thank you. See you. Bye-bye.
Bye.